Good morning. In our previous session, we have discussed about ion selective electrodes and construction working of glass electrode. Right. So, ion selective electrodes. What do you mean by ion selective electrodes? So, we have discussed glass electrode too. So, glass electrode, the first thing which we comes to our mind about glass electrode is determination of pH. So, why glass electrode is related to pH? Because the potential of glass electrode mainly depends upon concentration of pH and concentration of H plus ions. As the concentration of H plus ion varies, the potential also will vary. Right. So, H plus ion, why it is related to pH? Because negative logarithm of H plus ion is called as pH. So, in earlier days, we used to never have the pH meter. The pH meter, the pH used to determine the pH used to be a very tedious process. We used to determine the potential first, and by various calculations to determine the pH. We have some electrochemical calculations. Okay. So, the various applications of glass electrode is pH measurements, analysis of food, cosmetics, environmental regulations, soil acidity, etc. So, wherever pH comes, the glass electrode will be there. So, just when 4 decades back, so determination of pH was not so easy, but now instantaneously, when if I give you some sample of water or some sample, right, as determine the pH, will take the pH electrode, dip it, connect it to pH meter. I will tell me the pH of that particular sample in fraction of minute. But that was not the case in just 4 decades before. It was completely different. So how to determine the pH without pH meter? We'll just see. It is so in order to, I'll give you a sample. So we used to take the glass electrode, which used to act as a indicator electrode, standard calomel electrode, which acts as a reference electrode connected to the potentiometer. So we used to not have a potentiometer also, we used to have voltmeter connect to that. And how to measure the potential? Because we not have any digital potentiometer, we used to connect it to Wheatstone meter bridge. So you might have seen in your plates 2 how to determine the potential using Wheatstone meter bridge. So take the sample, glass electrode and calomel electrode, reference indicator electrodes are there connected to the voltmeter. So we're going to take a jockey and move it on the Wheatstone meter bridge. We have a 30 centimeter huge scale connected to the string. We'll take the jockey and move on the Wheatstone meter bridge. When you move on the Wheatstone meter bridge, so as soon as it stops, where it beeps, okay, when you get a beep sound, it will stop and record that the meter reading. From that meter reading, okay, it will stop and record the potential of that. Okay, the potential will be recorded. By measuring the potential or the meter reading, we're going to convert it into electrode potential or E cell potential will be recorded. By knowing the cell potential, we can calculate the pH. So let us see how to calculate the pH. So before that, let us see what are the electrochemical reactions occurring and how the cell can be represented. So the cell can be diagrammatic representation can be represented by like this. Hg2Cl2, that is mercury cell dipped in a known pH solution, glass membrane is glass electrode. The reaction which occurs at cathode, that is liberation of hydrogen. H plus undergoes reduction to get hydrogen. So in the above cell, so which will act as cathode, which will act as anode. So the above cell, calomel electrode will act as cathode and glass electrode will act as anode. So therefore, at cathode, reduction of H plus will occur. So once the cell potential is measured, okay, it will be substituted in the below reaction. So we know that E cell equals E cathode minus E anode. So E cathode, glass electrode acts as the cathode and calomel electrode will act as the anode. While substituting, you will get Eg is equal to Eg naught minus 0.0591 pH, that is electrode potential of the calomel electrode. So Eg equals Eg naught minus 0.0591 SR. So therefore pH is equal to Eg naught minus calomel electrode potential and E cell by 0.0591. Okay. So when you equate it to pH, we get this. Then substitute the electropotential of glass, standard electropotential of glass, and standard reference electrode, scalum electrode potential, and E cell potential we get, and divided by 0.0591, we get the pH. So this is how we used to determine the pH of the solutions. So any pH solution to be determined, pH of unknown solution to be determined, we used to determine by this method when pH meter was not available. Thank you.